All right, I think we can start slowly and steady. Good afternoon, everyone. So welcome to our AI native engineering webinar. Today we're gonna tell you a tale on how AMPECO rebuilt its software engine from the ground up. I'm Mariana. I'm director of the data strategy and architecture here at AMPECO, and I'll be your moderator. And we have crafted this discussion thinking about the questions that you would have and what you would like to know. So you're gonna hear from two of our leaders that just really completed something that in most of the companies are just, slide decks. A complete transformation from traditional product and software development to AI native engineering. So we will show, for example, real metrics, real results, and a bit of the story on how we ended up here. So I will introduce the speakers now. We have Orlin, our CEO, who made the bold and strategic bet to rebuild the whole ordeal. And we have Alexander Sash, our CTO, who architected the system that made this happen. Yeah. So we will discuss about 40 minutes, give it or take, and then we will take your questions. So you can, meantime, use the Q&A feature, submit the questions, and in the end, we will get to as many as we can. Okay, enough of me. Let's dive in. Yeah. So I think we can start with Orlin. Yeah. So Orlin, as far as I understand, you took a systematic approach to AI adoption. So you sort of identify your biggest bottleneck and then you rebuild the development process from the ground up. So I would like you to maybe walk us through that decision. So the decision of everything. What was this bottleneck and why did solving it required such a fundamental, dramatic transformation?
Yeah, absolutely. Well, Maria, first I would say you've probably heard me say this, but if you haven't, then many people in the company have for sure. That it's the company that's the product. It's not the product that's the product. I look at the company as the product. I'm a product guy, and as the company being the product, we've had a bottleneck in our product for a while, and it has been our ability to deliver on otherwise vetted and validated features that will bring value for the customers that use our platform and that we know we want to build. We have come up with this backlog, and this backlog has been always increasing. And that is us at the same time being probably one of the companies, if not the one that's been moving the fastest. We've been outpacing other competitors, companies doing similar things with more resources and for more time. So it's not that we haven't been efficient, we have been extremely efficient, we've been delivering very fast, and still we've been able to continue identifying more than what we can do that's worth doing. So I look at the system, and the system had a bottleneck, and you don't go and solve something on the periphery. I mean, you go and unclock what's blocking the system. And for us, this was our ability to build the product faster. And I've always wanted to build a product faster. It's not like something that last year I suddenly came to the realization, well, this is something we have to fix. It has been something that we've been always trying to to be better at. It's deliver faster, be able to do more, bring more value through the product that we are developing. But traditionally how this has been happening is you have to increase the team, you have to add more people to the product and engineering in order for them to be able to deliver more of what you want to build. Yes, you can tweak some processes so that you're more efficient, but you can only do so. I mean, and last year I asked Alex, let's sit down, and we've tried a few things with AI, so we had some experience already. Let's take a week to figure out how do we get to 20x of what we're doing now with AI. We assumed this would not be possible then at this moment, but it seemed already that this would be possible in the near future, in a few years maybe. So we decided to sit down and find out what would be this future state which would allow this to happen, and how do we map back from this to today. So what are the steps to go through? What are the changes we need to do in order to get to this point? And that's how it started probably 10 months ago. And yeah, I can share a little bit more, but maybe we can let Alex as well give his view on why we did and how we did it.
Yeah, so Sash, we are now full in what, 6 months in? So
Yeah.
what does the data say? Did it work? What are you seeing in terms of velocity, quality? Can you give us some number to chew?
Yeah. Well, we're not at 20x yet. That was the goal. So we're not completing the transformation, but we're about 4.5 times the productivity without changing the team, by the way. We just froze hiring when we decided to go through this transformation. So with the same team, we're doing 4.5 times more. And about the quality, because that's important, this was non-negotiable for us. So people are asking me right now, you're using AI, does that mean that we don't care about quality any longer? No, definitely not. We actually care more about quality, and AI can actually help. So we have increased 4.5 times the throughput, which means 400 times more features hit production every day. But we've stayed at the same total amount of bugs, which means that we've actually decreased the amount of bugs per feature, but by exactly the same amount. So that means that AI actually is much better at delivering working code than humans are, which frankly is not.
I mean, mind that. I mean, this is us using AI in a process where humans have are the guardians of what comes out of it. So I think it's mostly that what we've done is we haven't just increased the throughput. We've increased the throughput and increased the quality. And by the way, this is probably the first time I've seen our marketing use numbers that are lower than the actual numbers. Because I mean, probably because the campaign was started for the webinar a month ago, and then these were numbers. I was looking at what's the current state, and we are comparing the number of features changes to the product is the same by size we were doing before. Now compared to pre-Coda, Coda is how we call the cooperated dev agent, is how we call the agent we built. And we are comparing these throughput by saying how many were we able to deliver in a month before and how many are we be able to deliver now. I'm seeing the latest features is about 7x with and this week, taking a whole February so far as well. So yeah, it's and again, quality was not negotiable. That's the thing. I mean, we are not building. It's not a brand new product, so it's not something that's like see face. You can vibe code and you learn along the way, and you get some traction, and then you go back and refactor, harden, and so on. This had to happen in our existing product, which was already quite mature, and which is a mission critical platform for companies who are managing critical infrastructure. So there was this couldn't, from the start, we knew this couldn't mean we are going to slip and we are going to add more to lower the quality. We actually had to increase the quality, and this was one of the goals of everything we did.
I think that the beauty of it is that the transformation bit, that you actually did this while the plane was in midair. It was not a greenfield project. It was actually changing the entire process. So for example, before we talk about how it actually works at AMPECO, maybe Sash, you can take a step back and talk about the beginning of this tale. So what was the aha moment that you realized that oh, I need to rebuild everything?
Yeah, so Orly actually said that it was in June, I think. We sat down for a week to figure out how the engineering would look like in 2 years so we can prepare. So we started experimenting. We started working with Claude actually for the first time. And we've been using other tools before that. And we needed to validate some ideas. So we started small with a small task. Let's see how it does. Then we started being bolder and bolder. And everything that we tried, we figured out it was working. And we were actually surprised because the previous tools that we've been using didn't work this way. And Claude Code was different for the reason that it was able to basically sustain work for longer periods of time. And when it was actually done, the story was really done. It wasn't like you need to nudge it to continue working, which was an issue with other tools. So basically, at that point, we didn't find the boundary. We didn't find anything that we tried that it didn't manage to work. So we figured, yeah, maybe it's not going to be in 2 years, maybe it's right now, and we just missed it basically. So we sat down, and the first version of the cooperated dev agent, Coda, was released 1 or maybe 2 weeks after that. So it doesn't take a lot of time to develop that. Why? Because we actually used the AI to build itself. We didn't write anything by hand, and we haven't since, I would say.
Yeah, maybe we can dive deeper here on what it is actually that we built. So for me, it was seeing the capabilities of Claude Code as an agent itself. So we have an LLM that can code. I mean, if you give it a task, so you prompt it and it returns code, that's already good for something small. But the real magic was that it can use tools to do multiple steps to complete the task. So it would read code, it would create a plan, it would execute, it would be able to look at what's done and so far. So for me, the seeing that an agent can actually sustain this work over time is what clicked. Because we've been using before. We started with I think with Copilot, we've used Windsurf, Cursor. We've seen that LLMs can write code. That was already. I mean, we knew, and this is what's triggered. I mean, we knew LLMs can write good code. If it's a chunk that's very well defined. So, but then how do you build inside a product which is already complex and the agent that's able to sustain work is what clicked for me. And what we decided to do is we are going to build a workflow around it. And this workflow, it is not very different than what we were doing before anyway. So if we think about how we built a product before, we started with specification. I mean, say we've already decided what we want to do generally. We've identified the need. We've done the validation. This is what product work has happened before. But when a product manager has to come up with, okay, what is the change? What is the feature? What we're adding and how would it work? They would come up with a specification. This specification could be something very big. We call these feature proposals, which is eventually goes to an epic. An epic would be multiple stories or tasks that are more well defined. But we had this process in place already. So already this is how it worked to get to a specification. And then the specification is groomed with the engineers, meaning that then this is a handover process where the product manager brings in the engineer to get into the details, even though there have been some discussions before to come up with the specification. Then the engineer takes over. And what does the developer do? So first of all, they have to understand the context. I mean, they obviously, from the product manager, they would understand why we're building this, but how you are going to build it, even if it's in your domain, so to say, in things that you used to do, you have to look at what is going to be touching us. So you look at the code base to understand how this new thing fits into the existing code base, because this is not a brand new product. And then you would do this analysis and you come up with some, okay, I have to be careful about this thing and I have to consider this, and maybe we'll need to change something there as well. And then you've brought in the context into your own brain. So you've understood how this fits into what needs to be done. And then you have to break it down to tasks. So break it down to things that you have to do. I would edit this file here and I'll start with this thing. Maybe I'll start with a test for this thing. But you break it down in tasks. And then you'll start implementing these tasks and you check you verify your work. And these things, now we figured these are things that the agent can do. So let's give it a workflow to follow, and let's give it the tools to do these things. And then it should be able to complete this. And ideally, how do we get to the 20x? Ideally, this should happen in the background. So it's not something where previously we were using Windsurf and you were prompting it and it's doing work and it's saving you time. But it was never the writing of the code itself that was like the biggest bottleneck. It's the context switching, it's the fact that you have to do a lot of things in order to, you have to do this research, you have to do these things. Well, if these things are all done by an agent in the background, then you're not really as a developer working on one task. I mean, one story. I mean, you can have like 20 stories that are being worked on up until it's time for you to review the code. And eventually what we built and what Coda is, it's a workflow orchestrator where we have workflows for different aspects, or I mean, steps of the engineering product and engineering process, which are run. And in these steps, at some points, you would have an agent, which we use Claude Code as the agent to do the agentic steps, so to do the actual coding, or to open a browser to verify, or to write a test, and so on.
Yeah, so it's not really about the code itself. That's the easy bit part. It's about the orchestration of the entire workflow of, the grounding work to get that done. Yeah. So I was wondering, in this workflow that you just described, where do the humans step in? So what are the critical checkpoints that you would identify that, okay, now here we put a human?
Let's Alex talk about the developers, but I'll just take a little bit to talk about before we get to actually to the human developer, and talk about one of the first things we did actually with this was to make it, to give it in the hands of the product managers, so that the product managers can actually create a good specification. Because in order to specify, you have to understand the business need, you have to understand how this fits into the product strategy and so on. But also you have to understand how this would potentially, how does it work at the moment? How does it work in the product at the moment? And what are the limitations and the things you have to consider in order to build the feature that you start now imagining. And one of the first things we did was we actually started, I think one of the first commands that we did was to do a product review. So it was to get a story which is specified, so to get a small task specified by a product manager, and to give it to the agent. And it was technically just a command in Claude Code, and it was one which initially you were running manually. But this command would include instructions on how to validate the specification. And in order for the agent to be able to do this properly, you would put in the command what are the things that we want to have in a specification? What is the format? What are the things if we're building this, then we need to include this and this. Well, if it's a form, what are the validations? If it's an API and so on. But also, in order for the agent to be able to do the research in the code base, it has to understand the code base. So one of the first things that we actually had to do is create the necessary context in the project itself. So this is not the agent, it's about the project, and we have multiple projects, but one of the biggest ones is our backend. And to create the context so that the agent can answer these questions. Because in the end, it's about the agent being able to understand and put in context what is being asked in this specification so that it can evaluate the quality of specification. So I had to create our first Claude MD, which is, with Claude Code, this is the main context that is being loaded in the agent when you start it in the project. But it was not everything that you needed. I mean, we had to create some documentation, because you can read the code, and ideally, and so far, even before that, our rule has been that we don't have to annotate and put inline comments in the code. The code should be self-explanatory. Okay, but even if it is perfectly self-explanatory, there's always some part which lives outside of the code for the intent of why things work that way, how they connect to other systems. And these things which the agent needs in order to be able to do good code-based research. So we started with this, we started adding this. And don't think that we sit down and we took a week to figure out all of the context. It's just that we created a command for the code, for the product review, and the first result was not very good. And then we said, well, okay, what's missing then? I mean, it doesn't know about this and doesn't know about it. Let's tell it about this and create we'll put this in the Claude MD. We'll put this in a dedicated documentation for the UI. We'll put this in a coding standards that we have specific ways, for example, to think about the no comments and so on. And we started iterating on this, but we started from reviewing the specification, because it's Alex would talk about how this then goes to down the process. But the first thing that's where we hand over from a human to the agent is the specification, and it has to be good. It has to be good in order to outcome to be good after that, and we started with that. Alex, if you want to tell how it works after that and where the engineers.
So yeah, after that, initially, because the question was about what are the checkpoints. Initially, we had, as you said, the agent will do a plan. So we will do an implementation plan, technical analysis. It will do an acceptance test plan. And by the way, these were all things that we did anyways. We did before that. So we didn't invent anything new. We just took the processes that we already had and we figured out, okay, if I have to explain this process to a newcomer, basically to an engineer that I'm onboarding right now, what would I say to him? And those were actually the instructions that ended up in code. So at first, there was a checkpoint that the human engineer had to review the plan. And why did we have to do that? Because the plans were not very good. Why? Because what Tony said, we didn't have the proper context. It just didn't know something about the history of the company and why something worked the way it was, and it's just embedded in someone's memory from the team. So we had to take it out of the human heads and put it in files, basically, so that the agent can actually access that. But at some point, it turned out that the plans were good enough, and that was not necessary. So we removed the checkpoint. So right now, the agent plans, creates the plans, and then directly starts implementing them with no human oversight. So that's the important distinction here. There is no way for the human to intervene with the whole process. So from that point, you go to implementation, you implement one of the steps in the implementation plan, then you clean up start over. Basically, it's the same as if another engineer comes and picks up, sees what the first one has done and continues. Does all the implementation steps, then another agent comes in and does a code review. And we had to explain what a good code review means. Look for security vulnerabilities, performance, maintainability of the code, so on and so forth. And then give back the task to the engineer and say, I don't like this and that. So it's a loop, basically. It goes back, says, this is not correctly implemented, fix it. There is a bug, for instance, fix it. The engineer goes back and fixes it one by one and gives it for another code review, and so on. It's a loop. Then the code review says, right, I'm happy. It's fine.
The code review, just to be clear, I mean, that's an engineer, actually human engineer, who's reviewed the code, the implementation, and
No. I'm talking about.
You're still talking about how the process before it gets to an engineer. Okay.
Yeah. So at that point, you go to the QA engineer, which again is an AI agent that has to do the manual acceptance. So the manual acceptance will actually.
Alex, just to be clear, so what we're looking here is this process that we have now on the slides. All the blue things, these are AI. This is AI. So these are. So the architect, the engineer, then we have the code reviewer, then the QA. These are all different agents. In our case, technically, these are not really agents per se. These are workflows that we have that are triggered after the previous one has completed. But these are fresh context where we start Claude code with fresh context with different instructions to do as one of these steps. Like for example, to do a code review, it's one step and it does the code review. If it finds out some stuff, it would write down tasks, but it will not implement them and stop. And then the other workflow would start.
Yeah, and for the QA is the same thing. If it tests manually and if it finds issues, it gives it back to the engineer to fix. Basically the same way that you would do if you.
So for the QA, maybe here just to make it clear, we actually give it the tools to verify manually, same way a manual QA would do it. Like it has a browser, it would do API calls, it would open an app. So these are the things it would going to verify actually the implementation as if a human was doing it on a computer, right?
Exactly, yeah. And at that point, when it was happening, there were no failing tests, it would say that it's done. And it would hand it off for a review back to the human. But the important point here is that the review isn't just code review. So the human has to actually go through everything that the agents had done because they provided artifacts. So every test that was run, it wrote down what it did. It actually took screenshots, for instance. It took logs about what happened. And the human had to actually go through that and evaluate that all of the work done, not just the resulting code, was actually up to par. And at first, the humans actually launched the branch basically to make sure that it actually worked. Why? Because they didn't trust it, for instance. And also it was bad at first. Why? The same reason. You didn't know about stuff, so you had to fix whatever was wrong. But anyways, right now, the checkpoint that is remaining is for the engineer at the end. And another checkpoint that I didn't mention was actually before that. So we have an alignment sync that is between one engineer that's going to be responsible for the story and one product manager, where they basically align on what has to be done, not necessarily how, because that's the AI's work to figure out how, but exactly what has to be done so that the engineer can have the input as well.
So have the engineer and the product manager actually sign off on the specification, create the specification. So that's where we've put a lot of focus. And then in the end, we have the engineer evaluate and sign off on the actual implementation. So these are the human checkpoints in the process. Everything in between is the AI development agent.
The workflow, yeah. So I think that this is very illustrative from the engineering perspective. But for those in the audience that are not engineers, I think we could maybe give like a concrete example. So Orlin, for example, could you, for example, take us through a recent feature from the first conversation with a customer that a product manager has to actually the feature being deployed in production?
Yeah, let's take one which is relatively easy, but still would take way more time to develop if it's before. We just this morning we're doing these insights reviews where twice a week we look at insights. Insights are things that anyone from the company can log. Customer success talking to a customer, pre-sales talking to prospects, sales talking to prospects, industry analysis, getting insights from different organizations, and so on. So everyone can log an insight, and the insight it explains a certain need that may potentially be solved with something in our product. And this could be very high level, like for example, it could be an insight about I don't know, a new legislation coming in Italy that would affect how invoicing or billing has to be handled, or could be very specific, like for example, in a certain process and someone is using our product is lacking a way to filter the transactions by the partner, so by the site host, so only the transactions that happened on this partner's infrastructure. So take, for example, this lacking filter as something that's this morning we had a discussion about. Someone logged an insight. It was eventually we decided, well, we actually need a couple more filters there to cover the workflow. It's not exactly what the customer asked. They would need a little bit more, but a product manager takes this insight, feeds it to Claude Code, which is now the sparring partner for the product managers, launches Claude Code in the backend project in this case, because it's the filters would be added there, and would converse with Claude about how we are going to handle this. Do we add a filter? Do we have similar filters already? Would we what would the user experience would be like? Should you start typing? What are the options that are going to be shown there, and so on, and comes up with the requirements and clears up what needs to be done. And this is like, think about it, for this feature like this is like 5 minutes of conversation with Claude, and then you say create a story for this, and then we have a skill in Claude Code which knows that when we're creating a story for the backend, it would have to include this and that, and it would run again the agent to create the story, present it to the product manager, and product manager would see, and well, I'll make a correction here, I'll make a correction there, and it's ready to go. And ready to go means that from this point on, the story is specified. Now it's time for it to be aligned with an engineer. And because it's a simple story, probably what happens is we have this automation which selects stories in a certain state, in this case ready for grooming, and matches the developer that was going to work with this with the product manager, and adds to their calendar a grooming session to go and just look at these stories. And usually, I mean, there'll be like multiple stories of this type that are going to be part of this grooming session. So the grooming session comes, this story would be one of the many. This probably would just be like a quick sign off. Like the developer would just say, well, yeah, I understand what's needed here. It's well specified, no comments. We don't need to change anything. And what they would do is they would switch the story to another status, which is a release notes prep. This is a status which we indicate this story now we need to prepare the product update for this so that it goes into the knowledge base. People would know that we are doing this. And then we have a workflow that looks for these stories that need release notes preps, they need the product update. It will take the story to look at the epic. Is it something part of something bigger? How does it relate to other things in the product? And it will draft an article, so a page that would be published in the knowledge base and would now be in draft waiting to be published when it's released. And it would switch the status of the story to ready for development. And then an agent that's looking for stories that's ready for development takes over, takes the story, reads the story, and researches the context and creates an implementation plan. An implementation plan is like development tasks, and then another agent creates the acceptance task. So it looks at, okay, how are we going to test this? We're going to have to open the browser, look for the filter. Is it on the right location? Does it have the translation? Does it have the option? When I filter, do I find the proper results? And so on. So it's like what a manual QA, so someone that has to test the software, would create as a plan. How do I break this thing? And by doing so, confirm that it actually works and doesn't break. So the agent would create this plan. And then when the development plan and the QA plan they are ready, then the implementation workflow starts. And it takes one of the development tasks, implements it. And by the way, because we've instructed to do test-driven development, probably the first task in this story, not probably because I have the story actually being done here, I know what it created. It created a test first to find that there is no such filter. And then it's created the implementation of actually having the filter and so on. It would go through this process, complete each individual dev tasks. Then the agent that does the acceptance would do the acceptance, sign off on the acceptance, check the checkboxes on each of the acceptance tasks. Then the code reviewer, if there's something wrong, it would open tasks, it would loop until they're done. And eventually it would send a notification to the owner, which is the developer who did the grooming, so the human developer that is responsible for the task, and would tell them the implementation of this story is ready now for review. And then the developer has to open, we're using GitLab, which is where you see these code changes, and to open the code, see the code changes, see what's changed, see the artifacts. So what was the tested, what was the screenshots taken, and so on. And if the developer would open up the project, would test, filter is there, it's working as it has to work, see that everything's right. If there are no comments, the developer would sign off on this, merge it so that it would be released tomorrow morning with the many other tasks like this. If you think about it, it sounded like a lot, but think that the thing that's a lot, this is all happening in the background. The human work was in this half-hour grooming session when the developer and the product manager for some similar stories probably took like 5 minutes per story, and for bigger ones, they may need way longer. And then in the end, to do the code review and sign off on the story. And then the developer can do an enormous amount of stories like this, where they are theirs, they're the ones that sign off, they've ensured they're well developed, but they haven't done the whole process in between.
Yeah, we might have taken more time to explain how this works than actually a feature gets to be implemented, in real life.
Yeah,
But
for a feature like this, pretty much that's true.
yeah, so
Just want to highlight something real quick that Orly said I think is important, because previously there were grooming sessions before that, but the product engineer had no way to spar with an engineer before that to confirm that their idea
You mean
was
the
good.
product manager? Because I mean, previously
manager.
it was a product manager only.
Yeah, exactly. So why right now the grooming sessions are quick, because that's an important distinction, is because the product manager actually used Claude Code, which is basically he talked with an engineer about the feature. So that's why we get quick sign-offs and there are more sanity checks. And again, same reason why the code reviews don't go through 100 passes of, no, this is not the way we do it. If this is not the way we do it, then there is something upstream that the agent should know. Same with the previous checkpoint. So the point being that right now these are quick sign-offs, and when we get to a confidence level that there are no comments for code reviews, for instance, we're even going to stop doing code reviews. because the way to move fast.
Human code reviews. I mean, this issue only, and I think it's a very important thing. Eventually, I mean, what we're aiming to do to build is, I think everyone that's in software should be aiming to build is like a lights out factory. So something that works 24/7. There's no humans involved. You have an input, and you have the output, and the output is production ready. So it's the produce, it's done, and it's to the quality standards that the organization has. What happens in between should be fully unattended and scaling indefinitely, and that's what we're aiming for.
So we started talking about the bottleneck that you identified last year. So what's the bottleneck now if we are, moving this fast?
Right now, I would say it's probably code reviews right now. But having said that, we're actually moving away from code reviews because each code review actually gets reviewed by AI afterwards, meaning the feedback that the human gave the AI is reviewed afterwards to figure out what the agent should have known in order not to make this mistake in the future. So this is actually a self-improvement loop that runs on top of all of this, which means that every code review that you have to say you failed at this because you didn't know this and this to the AI agent, it will feedback and fix itself, basically, add that knowledge in. So the next task that you develop won't have that problem. So I'm guessing that in the near future, hopefully, the bottleneck will move upstream into figuring out what we have to build, what is worth existing, rather. And this is basically the transformation that I believe every engineer will have to go through in the coming months.
Yeah, and in honesty, I have to say we are not there yet. I mean, I still have a backlog of things that we want to do and we have vetted and validated, and we still haven't delivered. They're not ready for code review yet. So there's still a backlog to siphon through. But I mean, previously the way we work with the insights is when we validate something and say, well, okay, we're going to solve this with a feature or product change. We assign a product manager, but in order for us to make a commitment, we're going to do it. We work on these 2-week development cycles. So we had these future iterations, 2-week iterations, so which is like a group of stories, work items that we are going to work on. And we would create such for the next 3 months was initially. And if we couldn't fit this in one of these, because there's a cap, the cap is we know how many of these features we are delivering every month, then we can't say that we are committing to this. I mean, we would put it in a backlog and we may return back to it when it's, so there's a lot of competition there. And then at some point we had this for 6 months. So we have 6 months worth of work that we've committed to. And then we finish this 2 weeks iteration and there's some spillover and we have to move things back and we have to move things back. And there are things that have been moving back because they are more quality of life. But I mean, we've known that we want to do them, but we've pushed them back. It was for the first time in the past 2 months that we started bringing things forward. So things that are in the backlog further down. And we now have, well, this team actually, they have capacity. Let's bring something sooner. So we're bringing them sooner rather than pushing them back. But we still have a backlog of things that we have validated that we want to do. And the other thing is, as you increase the surface of what's there and what's possible, also the customers, whoever is using the product, they come up with more ideas of how they can further get more value for this. I mean, we can, we can even streamline the process, our internal process a little bit more if you did this in your product, or we can then go and chase this opportunity which previously we don't have, or we can try this model pricing or different that we previously can't if you just deliver this feature and so on. So I don't think it's like a race that we are going to win and end up we don't have anything to do, but we will probably move the bottleneck to being able to more precisely vet and validate what is worth doing. Because one of the things with AI is, I mean, say you build a perfect machine that can produce what you wish for. The quality of what you wish for is then what you compete on. So it's about this judgment that you have to exercise on what to build, and not your ability to build. So next bottleneck probably would be there. So we have had so far a very good process with the same size, or I mean, as big as it used to be before, when we were strongly competing for the resources to build things.
All right. So maybe now we can get a bit morbid and talk about death. So, like, for you to get to this point, you had to kill something. So you need to kill all processes, and you need to change people's perceptions on how things are actually working internally. So after the June AMPECO's June summit, Sesh announced for the whole company that no one should be writing code by the end of the year.
No, he said no one would be allowed to write code. So.
It's even worse. Yes. So how did you have to kill these old processes internally to make this happen? And for example, why not just do an incremental change bit by bit so people could get, used, because it was, part of my French, quite, violent, the way that you just push that through and champion that through the entire organization. Yeah. So that's the question. How did you kill the old process and implement a new one?
So maybe the question is, why did we do it first? And the reason behind it is that there is no way to do this incrementally, I think, because if you do it incrementally, then it's a human using a tool. And when we've been seeing that there has been going on for 1 year at least in AMPECO. And the problem is, and by the way, that's why a lot of companies say AI is bad and we're actually slower with AI, is because if you're actually driving the tool and you're making sure that it doesn't mess up along the way, all of that information that you're feeding it is lost, basically. There is no build-up. This context is given to one model, and when you close the window, it's gone. The real deal should be, if the tool messes up, figure out why it messed up and fix the context. So build the machine, build the factory. That was the point. And there's no way, I think, to build a factory if no one is using the factory and everyone's using the old ways. So that's why we had to do it violently, I would say. And by the way, it wasn't a fast transition. Just because I say that no one should be writing code doesn't mean that everyone listens. And to be frank, only in the past 2 months, we actually did an even more violent thing, which was we actually installed automated agents that don't run on anyone's machine. They don't run in the cloud. And they actually hoist work off of people, meaning that the stories will be automatically taken and implemented. So you have no chance to actually take it for yourself and implement it yourself. And I would say that that's probably more to do with trust, because basically engineers don't trust that it's going to do good work. But it's a chicken and egg thing. So if you don't trust it, you won't find out how it messes up, and you won't be able to improve the machine. That's the whole thing. That's why we chose this way. And you have to, why we kill the whole process is because most of the processes that we had, if not all, were built around the idea that we should keep engineers safe and allow them to work. What does work mean? Write code. So all of the agile stuff that we've been doing, the daily stand-ups, the everything is central around that. Engineering is building stuff is expensive, so we should protect it. And right now that's not the case any longer. So it doesn't make sense to use the same process for this new world, I think. So anyone going through this will have to start over.
Yeah, I think also it's very important to say that I think we have an amazing team that's been very receptive and willing to adopt this. Because I mean, that's the other thing. I did have some significant worries when we embarked on this, that this would be a transformation which would also create a lot of turmoil internally. Because I thought, well, people wouldn't be happy. They would maybe I'm overgeneralizing, but I thought there'd be more people who would see this as unwanted, as not something that's it's just about. I mean, it's new, and I'm afraid about the new thing. It's that I wouldn't want at all, and I would say no, and I'll sabotage it if it comes to that. There was none of this. I mean, yeah, there was. It took us pulling the rug from the team at some point in order to get them to move this distrust to further down the line, because I don't want the developers to blindly trust the AI agent. On the contrary, we want the developers to be the guardians of the quality of what we bring out. Only we don't want them to do it by manually doing the work. We want them to do it by improving the machine. So this trust, I think, is very important. I don't trust the agent as well. I mean, I'm doing a lot of it myself, but I don't trust it. I strive to make it trustworthy, but I mean, I don't trust it, and I think that's quite important. And I'm very satisfied with how it happened. I mean, everyone on the team is now using it. People are contributing and building the context, building the agent. We have even some conflicting ideas about what to build and how to do things, which is great because I mean, this is what you want to see. It's in anything new, you don't know the right path, so we have to figure it out what the right path is, and you need competing ideas. This means people are engaged and are thinking about it and are trying to figure out how to make it work.
Yes, I saw in the questions that we have a few more questions. People are really interested about this, so I will pick it up in the Q&A afterwards about this process, like accepting how the team actually welcomed the changes. So now I would like us to just talk a little bit before we finish about the customer impact. So for Orlin, for our customers, for I don't know, a CPO running charging network, what does this actually mean for them? So how does this internal transformation actually yields and translate to their business?
Well, mostly it means that they'll be getting more value out of the product that we're providing for their business. Meaning that we'll be able to faster act on the things that we identify that would make their work easier or make them more successful in their own business. Because in the end, the product that we're building, we're not using it. The product that we're building is our customers are using it to manage their business and operations and to grow them. And our ability to deliver on things which would make them more successful in doing so has an influence on their ability to grow and have their business be more efficient and work better. So we have already, I think, a very good process of identifying these things. We work very closely with customers. Also, for the way we have positioned what we do is we don't work with that many organizations. We work with large ones so that we have very hands-on. We have an account manager that has a very close relationship, weekly and even sometimes daily contact with operational people on the side of the customer. So we get to understand and to know how our product can improve or add value, and now we can act more quickly on this. I mean, we have in the past weeks few examples where from idea to delivery, it was 1 or 2 days. Last Thursday, for example, there was one thing which was quite important for one of our customers. It was something that came up unexpectedly, not something that they planned for, but it would really make their life easier if they were able to have it. And we delivered it from Wednesdays when the conversation was between the customer success manager and them. On Thursday, it was ready. And the only reason it didn't release on Friday is we don't do Friday releases. We do daily releases, but we do Monday to Thursday. And then we release it on Monday. So if they had just been just 1 day quicker on communicating this, they would have gotten it the next day. So, and also this allows us to take more chances on things that are not proven, where the customer has they want to experiment. And there's a lot of things in our industry that are worth experimenting, but have been too expensive to do up until now for the development that's needed in order to make this experiment. And now we are saying more and more yes to these things, and we are able to deliver those not in 6 months, but in 6 weeks. Now going to 2 weeks, maybe 2 days very soon.
Yeah, so I mean, I can attest that you were both really hands-on. You were full into the process, and that's very clear for the organization. And I wanted to ask you, for example, for other leaders out there, so other CTOs, CEOs, and so on, that would like to implement something similar, where should they start from the technical point of view, Sasha, and also from, the whole organizational point of view, Orlin? Where should they begin?
Well, I think Alex would probably say similar things, but quickly, my view is you have to lead by example on these things because it's a transformation. It's something new. I mean, you have to show the way, not just tell people this is the way. Now find me how we do it. So you have to, as a leader, you have to both want and express and lead in a certain direction. In this case, it's transformation. In our case, on how we do things internally, and that it started with engineering. I mean, but it continues now across the organization in all departments. But also we have to show, not just say, tell, but also show and really own it. I mean, we together with Alex, I mean, we've been the ones, the first power users of what we've been building, and we've been the one hitting all the roadblocks first and breaking our heads there before we wanted everyone else to do the same thing. So I think this is one of these things that, at least for similar size for organizations which are not and not immensely huge, it has to happen top down. Maybe in very large organizations, it's may be easier if it happens bottom up. But for organizations of a few hundred people, I think the only way to do it is top down.
So no delegation of the transformation. You need to.
Yeah. By the way, it's an interesting thing. We had a workshop where we with a few other companies, we were showing them how we do it. It's a full day workshop, and one of the key takeaways that everyone shared was, well, they asked us like, who is the team that's doing this, or did you get external help on who is implementing it? And the thing that's very important to understand is this doesn't take like a dedicated team to do this. I mean, this is the kind of thing that you spearhead with a couple of people, and ideally this would be your CTO, like I had Alex here do it. It takes a few days to start it rolling, and then you have to engage other people to have this as part of their job, not put it in this is this team's job and this is the AI implementation department that's going to handle how we become AI native. This wouldn't work.
Right. Any regrets? Anything you would have done different, Sash, maybe?
From my point of view, I really hate that I didn't start with Claude Code early, because Claude Code was out in February of last year. And I actually have a policy to wait for a couple of months for every new tool to stabilize, which is an old policy. I've thrown that away since then because it doesn't make sense in the new world. What I mean is, right now, if you're using a tool that was built in January this year, you're behind. You should be using February's tools. And this will only accelerate.
Then why are we not using OpenClaw, for example? That's my question.
Because I'm scared of it, to be frank. Yeah, so my advice would be start now. If you're wondering where is a good time, are the models good enough? They've been good enough for quite some time now.
I think since Sonnet 3.5, I mean, the models have been more than good enough to write good code. It hasn't been the models being a capability that's been the limiting factor.
And the other thing is not just code. So if you have any knowledge work, Claude Code can do it. OpenClaw actually showed that exactly, because OpenClaw actually underneath it is Claude Code. It's kind of a wrapper. So yeah, if you have anything, you have to write a dissertation, for instance. Yeah, it can absolutely do it. No issues. So start now and do it yourself. Don't hire, don't delegate, do it yourself. You have to figure out what this can do, and it won't take a lot of time.
And I mean, the thing is, if you think about it, I mean, in other, if you have to step into something that's new for you, but everyone else has been in this for years. You have an uphill battle, but here everyone's new. I mean, Anthropic's team, they're new in this. I mean, they're using Claude Code for a year. They're not more than a year, right? I mean, because it doesn't exist. So there isn't that much that you have to learn, and you don't need some amazing external expertise because it hasn't had the time to compound really that much. So the entry point is actually, the entry barrier is very low. So you should just take on a few experiments if
Let's
you
do
are not
it.
doing this, and just move a little bit further what you think is capable, and then start compounding on your own machine, whatever it solves, whether it's for you, it's very important to build a software product, a software company, or to solve operational bottlenecks that if you're not a software company, then this is what you need to do.
And I just want to make a point real quick. I don't know if we have time, but if right now what we're doing, the guys that are building the AI tools, they're using the same techniques. They're even farther along than we are. And that means that they can actually ship new features incredibly quickly because they're not doing that. The AI is shipping itself, which means that the rate of acceleration will continue to move on. And you have to get in the business now because it's hard for me to keep up with everything that's new. That's going to just keep accelerating. So if you start now and you start using that, you have to use agents in order to keep up with the rate of progress, I would say.
All right, I think we can move to dessert. So let's look at the questions. And yeah, thank you both. I think we covered everything that we had in the plan, the transformation, the technical architecture, the business impact, and even some heart-to-heart advice on the do's and don'ts of this journey. So I'll move to the question. Give me 1 second. Okay, let's start with the engineering part. So there is many questions I see here that are touching similar topics. So I will pick one that sort of like translates, I think, everything. There's a lot of questions about testing. So for example, this question from Sweden. So how did you ensure that quality tests were written to prevent the agents from hallucinating both the code and the tests?
Really good question. So first of all, this isn't a greenfield product. We've been building this for 7 years now, 8. And our approach to building quality software, at least from my perspective, was always I wanted to have a process where I could actually take a junior developer first day and get him to write a feature and ship it to production. And I would be absolutely sure that he can't break anything. And the way to do that is you have a lot of automated testing. So we already had a suite of over 20,000, I think, tests written. So the agent just had that guardrail to work with, and he actually added new tests. The way to stop hallucinations is a bit different because what is a hallucination? So a hallucination happens for two reasons. First of all, the agent can run out of context, which means that the context window. That means it can work for a long time and it starts forgetting basically stuff that's been going on at the beginning of the conversation. And then it starts to fill in the gaps with something that he just makes up. The other way is he doesn't have the context. So he doesn't know something key for your system and there's no way to read it from your code base. Again, the agent will just fill up the gaps with hallucinations. So the way to remove that, first of all, do small iterative steps. That's why we clean the clone testing. We have separate agents doing small stuff, so we don't fill it up. And the second way is, if it does hallucinate something, figure out why. And the way to figure out why is ask it. Basically, that's how you debug an agent. You just ask it, and it tells you. And you just improve the knowledge gaps, because there's always some kind of knowledge gap that has to be improved in order to prevent this.
And I think it's very important to understand, this is not a one-shot thing. So you start the agent to do the code-based research to come up with the technical analysis. You stop there and you start a fresh one, different system prompt or command in this case, because you're not really replacing the system prompt in every instance, that has a different task. Review the technical analysis. So now this one, it's aiming to find the gaps. So it's not the same agent filling in and protecting itself from mistakes. It's another agent that actually now has the purpose of its job is to actually find the gaps. And then you do this, and then you have another one that's consolidates, and then you have another one that does the plan, and then each task is fulfilled by one. So if you have a test to write, one agent builds a test and stops, and then a fresh one has to build a feature that has to pass this test and stops, and so on. So it's not one agent that you give the whole thing to build that can then start filling the gaps, trying to, well, okay, I'll just game the test so that it passes, because my aim is to finish. My aim is to complete the tasks, because in the end, I mean, these LLMs are trained to complete the task, and if you give it too many things to do, it would try to just complete the task. But if the task is to fail the other one, or to check the other one, but completing the tasks means that it has to find the gaps, it has to find the problem. So these principles of fresh agents doing one job and then another one verifying and then another one doing fresh job and so on, this helps a lot to avoid such problems.
And that's the main difference between what we're doing and vibe coding, by the way, because in vibe coding, you're not doing that. You have one agent and you're just constantly talking to it, saying, yeah, fix that, and you start to fight with it, basically, which is pointless.
Well,
Yeah.
if you see how the tools are evolving, like Claude Code from the beginning until now, you can see that they're building more and more this into the tool. So there's a realization that also the tool builders are doing. Like now you had to have a plan which is just like one document. Now you have a plan which is actually something that has tasks which are long-lived, and then sub-agents that are not the main agent would complete, and then the sub-agent would orchestrate, and so on. So these are things that many of the tools are going in this direction, but the things they are lacking, they're filling in the process. So I think they'll be more and more better and better in doing a robust process. But what they're not going to bring is a context. So your product, your project has to be the one that compounds on the context, has the right context in the right amount, not misleading, not too bloated, in the right place for the agents to take advantage of.
We were supposed to close around this time, but I will keep pushing you a little bit if that's okay. And I see that there's a lot of people still in the audience, so I assume that this is a signal that there's still interest. Yeah. So I think this is a good one.
Maybe just for anyone that may drop off here, given that we're at time, I think there was a lot of more technical people in the audience that probably would benefit from knowing more about how exactly we've done things. For this, I would say for everyone that has been that has registered and everyone that's going to register on demand, we're going to share a more in-depth article that goes into more into the technical details and how we've built this. And also, I know that we are preparing an ebook that goes even deeper into this. That's in a couple of weeks, maybe 2-3 weeks, we are going to be able to release, and we are going to share this with everyone in the audience, which is more technical. I mean, it's more for the CTOs and the engineering managers rather than the business people. If you are one of those, we'll share some resource with you that can be useful, and you can then upload them to Notebook LM and let it summarize and create your podcast or something, or just give it to Claude Codes and then ask away and so on. Yeah.
So I think that this is a good one because I can see the logic of this question. So this person from Lithuania is asking, keep in mind your platform's code size and scale. Did you perform code refactoring before AI agent implementation and the workflows? I think it's trying to understand how much groundwork you had to do before all of this. Yeah.
Well, to be frank, we actually did a lot more afterwards because it was cheap to do. That was the main issue. Because if you think about it, refactoring in the age of AI with an AI native company is a dream come true for every engineer, because you need no coordination if you're at the right level, that is. So you have to figure out what to build, which is always important, and then you let the agent do it. But as to whether we had to refactor, yeah, we did have to refactor, but you have to understand there's nothing specific about this. Meaning, if something was blocking you from being performant beforehand because it was bugging humans, basically it was, let's say, hard to understand code, really obfuscated, really complex. It's hard for humans as well. So that's something that you should refactor anyways. And that's going to be hard for an AI agent to understand as well. But again, if you just figure out, okay, this is the problem, and I have an idea on what exactly it should look like, which is always the main thing to focus on, what it should be, then it can do it for you. You don't have to refactor it yourself. So I would say, no, don't refactor beforehand. you're going to figure out what to refactor while you're building the agents. Because
I mean, if you just take first 2 months of implementation of deployment, how much of what we did was refactoring due to make it work for agents? I mean, single digit percent. Like, I mean, we didn't have to like in order for this to make it work, we didn't have to make a huge effort to refactor something. It was like some documentation was up to date and out of date, and it is in the project. It doesn't have to be there. Maybe some things like this, or we have some conflicting code and not allow things like comments in the code. We have to clean them up, stuff like this, which is very small, so and iterative. So we didn't sit down and like do a huge refactoring to make this work.
But I'll give you an example on that. So we had a halfway refactoring of our factories, which is basically the way you see the database. And they would do two flavors of them. And the agent constantly, because the way agent figures out what to build is look at the other code and assume, yeah, that's the way it should be done.
As a pattern.
That's a pattern. And depending on which part of the code it could look at the legacy one or the new one. So we were like, okay, maybe we should try to explain what we really want. And it was like, no, we don't have to explain it. We just have to launch a task to fix it. And 15 minutes later, it was fixed. So that was a better way to fix the context problem, I would say.
Yeah.
We have a lot of questions that are not really about the AI, but they are about humans. I think they are very interesting to touch. I like this one very much. So this is from Singapore. So as engineers move from writing code to validating agent-generated output, how do you prevent reviewer fatigue in senior engineers or a decline in deep system knowledge among junior engineers who may never have written that code manually?
That's a great question. So the point is that our end goal is not for the engineers to review the code, right? So it will be technically impossible to do that because the AI, it will work 24/7. It won't get tired. It will produce code all the time. So you have to figure that this is a lot of merge requests that you have to look at. And it will become really quickly impossible for you to look through all of them. So the point here is you have to look at enough to fix the machine, not to fix the code. And that's a different mindset, mind you. And how do you prevent the fatigue? It's a new thing that you have to think about. So it's a new problem. I don't think that our engineers are fatigued because of that, because fatigue is you have to do the same boring stuff over and over. But this isn't boring because, again, we're not asking the engineers to fix the code. We're asking them to figure out why the code was broken in the first place. What was the other question? The second part?
I have something to add here. See how the fatigue already forgetting the questions so quickly. It's the attention span of the senior engineers. It's narrowing.
The fatigue for the senior, and then how do you help
the
juniors?
Previously, when you're looking for engineer for a job, I mean, you want to have like I don't know, 5 years experience with this or 4 years experience with that. What were we saying when you're looking for this experience? We were looking for signals that you have been doing this long enough so that you hit enough tough problems to move up and become more senior and better at understanding why and how these things work. Now with AI, this is condensed significantly. So you're hitting the hard problems so much offer because the boring stuff is handled by the AI. And then when do you need to step in to solve the really hard problems? And then you're even in better position to solve them because you still have the AI as a counterparty to talk through, to ask them why, to understand. But eventually you're solving more and more difficult problems way more often. So these five years experience that you previously needed in order to get to a point where you're good enough to be considered mid-level or senior in certain technology, now you can get this in 5 months. Maybe you can get it in 5 weeks if you're the type of person that can learn fast. But I mean, the thing is, most people in engineering, I mean, they're good learners. I mean, they haven't been working on something that's stale. Technologies have been changing, and this is in a constant learning experience for engineers, software engineers, even before. Now you get to do more of the learning more often, so you can advance faster. And this is true for a senior, this is true for a junior as well. I mean, a junior previously, it was more like an apprenticeship. I mean, you had to have some guide you through it because you can't solve anything on your own. You can't do the big things on your own, but you have to learn about the big things, right? Now you can do a lot of the big things without understanding them, but you can ask the AI, you can ask the agent, you can converse with a senior at your own pace and explore and learn about the difficult things without having to have someone that has the patience and the time to work with you, which previously you needed a mentor, you needed a senior to do this for you. So these two things are true at the same time. Entry-level jobs, I think at the moment, they're way less, they're way fewer of those, just because the value that you can get from a senior engineer with the tools that you have at the moment is enormous. But at the same time, also the ability to learn and advance in this job without having to do an entry-level job and do this apprentice kind of model, it's also now at a totally new different level. I mean, you can, on your own, as a junior, advance in months to a level where previously you needed to work a couple of years in a company in order to get this experience.
There are a couple of questions about the team. There's one that is about the dev team size. I think that this person is referring to the team size. So were there any layoffs? What roles became obsolete, and which you think that will need more support?
Which rules?
Roles. Yeah. So it's
by the way, just quickly, there have been no layoffs. We did a hiring freeze, and it was mostly because we didn't know. I think we are just about figuring it out. What are the new requirements? So what are we looking for from now on in order to excel and to continue growing with people? Because there's a reason we are keeping track of how much faster and how much more we're delivering by doing multiples to before on the same team size. Because in the end, I mean, you would still have people that are leading this. And then the question is, what are the qualities and the competencies that you need in order to be successful in this new environment? This, I think no one has the absolutely right answer yet, but I know it is different. I know it is different than what it used to be. Again, if I was to put a job offer now, a job posting now, and have to look for a specific tech stack and a number of years experience in this tech stack, this would not really tell me much about the capabilities of this person to deliver in this current new environment. And we're looking to learn this with our existing team so that then we can say, okay, that's what we need because we now have it. Let's look for people that have these qualities to join us and continue growing. But again, no layoffs, and we will continue actually growing with people. We have so much more that we want to do. So we're not, we've not exceeded everything that's possible. And yeah.
And I just want to make a quick comment here because Orlin just said it, but I want to highlight it. We have a great team. And what makes it great is that everyone is flexible and willing to learn. They're eager to learn, rather. That's why they work in a company that deals with EV charging. It's a new field. So there's no point in laying off because we don't have people that don't want to learn, basically. But yeah, I would say that that's the distinction. You have to be willing to change because what we're asking you to do basically changed completely, I would say. Not completely. It actually moved upstream, is more technically correct.
All right, gentlemen, there's a lot of questions about technicalities here that I think that will be covered in the materials that we are preparing. So I apologize. Otherwise we would have been here.
I would want one more question. There was a question about pricing. I really want to see this one because I think this is a very important one, and it may be seen as like a sensitive one. I mean, but someone asked about how does this affect the pricing?
The pricing,
we are
yes.
a software company. We have a software product. How does all of this affect how we price it? What's the willingness to pay? I think this is a very important also thing to touch on for everyone that's in the on both sides, whether you are a vendor, someone that's building software and your software is your product and you're selling it, whatever the model is, or you're the buyer and you are the one that is using software that now can be built so much faster and obviously more efficiently. So I think it's one that's quite interesting. I think we can.
Yeah, this question about pricing was actually very open-ended. It was just what it is, the impact on pricing, that this type of transformation had the pricing towards your customers. That was the question. So just go for it.
Yeah. So I think from everything that we've explained, you should already get the idea that we can do so much more with the same resources now when it comes to building the software. Then the other thing is, so do others. I don't think this is unique. I think maybe in some aspects we may be a little bit ahead of the curve, but this what we've built and how we are doing it is how everyone should be and will be doing it if they are not already, and some are even ahead and doing it even faster. So what does it tell you about software? So does this mean the software is less valuable now, and that it has to cost less? I think it can do so much more. This is what's now, and the question is, if you can't do more that is valuable, so that you can sustain or even increase the value that your software brings to whoever your customer is, then the only way is to then lower the price, because now you can do it with few less resources to build. I think we're not in this position here for two reasons. First of all, is there's a reason we have this huge backlog of things that are worth doing, because these are things that are worth doing for our customers, and they're worth because they have value that if they were able to have this, they would do more in terms of their business, or they will do less in terms of their overhead. So they should either save them money or make them money. And by building more things that either save our customers money or make them money, I think we're also increasing the value of the software building. The other thing is, though, this is not just software. I mean, it's not just features. Like, I mean, what we as a company are building, we're building a platform that actually is running infrastructure. So we started with this. Quality was not at all a compromise that we can do. But the most valuable thing that we're bringing here is actually stability and reliability, because it doesn't matter how efficient you are in solving a problem if your platform is the one that's causing you downtime, like, for example, or it's the one that's damaging your operations. That's the trade-off is so huge that it doesn't matter how many features it has. And I think for any software that's running your business in one way or another, whether it's running physical infrastructure or it's running mission critical operations, the value of having someone that's actually is being able to deliver on the stability and the reliability and the performance of this is not at all diminished by the speed that features can be added with AI. Because the thing about AI is, I mean, it's helpful in that regard as well, but it's not running the infrastructure. It's not guaranteeing the stability. It's the process in place. It's the way you're building this software, and then the way you're maintaining and the way you're serving that guarantees this. And I think that part is way more difficult to offset with AI agents.
Yes. All right. Any closing remarks, or should we finish this up? I think we are at the time, but this was very good. It was very nice to host this and to show this to the audience, because I've been part of this tsunami, and it's good to put into words so others maybe can try at home, you know. So I want to thank you both, Sasha and Norlene, for taking the time, and especially our guests for enduring almost 1.5 hours of conversation with us.
Yeah, but I mean, if you didn't bore you and you want more, the thing is, we are both on LinkedIn. We're not on X very active, so I mean, find us on LinkedIn. That's the thing. Engage there. These are topics which you can see. Obviously, we are passionate about, and I think we have some interesting perspective. Whether it's the right one, who can say? I mean, but it has given positive results for what we are measuring. So yeah, engage with us. We'll be happy to continue a conversation even outside of this webinar.
Yes, and the recording will be available within 24 hours, so I was promised. You will receive an email with the link, and all the resources that Orlene mentioned will also be available shortly. If you're interested in learning more about AMPECO, please do contact us. Let's discuss this a bit closer. There are new announcements coming next month about new AI features in the platform. So stay tuned. I hope this was as pleasant as it was for me for you. And see you next time. Thanks again. And that's about it.